And again, it's this turbine wheel here that I cut using my homemade CNC mill, and did a wonderful job. It's laid out to be kind of a compromise between a standard reaction turbine and the impact type. So the blades actually, between the throat, they diverge a little bit, which of course increases the velocity and helps gain, I hope, a little more efficiency out of the steam. But running on compressed air, it won't be any more efficient than just a standard reaction turbine. Okay, here we go. And now we're taking a look at the actual turbine generator. The generator portion itself is back here, and there's a half shaft connecting it to the turbine, and that functions as a universal joint. And then the portion here contains the ball bearing sets that keep the turbine stable. And then when going around towards the front, get to see the turbine itself, and notice that the actual nozzle and so on is made of soft copper. That's so it can be bent and changed and manipulated quite easily. Okay, so what we're going to do now is we're going to plug in the compressor and run the thing on compressed air. Remember, this is really designed to run on steam, so we're not going to get that much out of it, simply because the combination of the impulse and reaction feature, it's mainly working on impulse at this point. But it should still work quite nicely, enough to be able to allow us to throttle down and run the streetcar. So we'll see what happens. You're going to hear a lot of noise now because the compressor is going to be switched on. Now I want to make sure that we don't get it running too fast. Okay, so that's about the slowest speed we can get it to run. Let's see how many RPM we got going here. So right there it's running about 1400 RPM. Very slow. Let's crank it up a little bit. Now that's about as fast as I want it to go, because it'll jump the tracks if I go any faster. Let's see what it's doing now. So right there it's doing about 5,500 RPM, and that's kind of as fast as I want it to go. Now I could open it up substantially more, but it'll jump the tracks. What I'll do is I'll take the streetcar off of it, remove the load from the generator, and you'll hear it crank up immediately. Without a load like that, it's running considerably faster. That was about 9,500 RPM. And as I said, I've had it up to 20,000, so matter of fact, I'll run it up as fast as I can for a few seconds just to let you hear it. Now that generator probably is putting about 80 pounds on it, but that's way too much more than I need. So that's where we're going to stop it from now. And as you can see, this unit will in fact make a nice drive mechanism for any electrically operated boat or whatever you want to use it on. It's got more than enough electrical output to run a model boat or model train or anything you want to, and it can be made much more compact. and I'm actually thinking of cranking out an axial version of it. But again, to point out some of the features, again, we got a Lexan, so you can actually see the blades moving all the way around. It's got a combination of a reaction and an impulse on the pitch and the shape of the blades. Again, here's what they're cut out when they are cut out on my CNC mill, and you can download a picture of that being machined, actually a video as well, and as well as the one operating on live steam. And it's working quite well, so I'm very pleased with it. Of course, this, by having it run turbine electric like this, it obviates the need for running a gearing system in it, which is nice. I mean, it does simplify things a lot. The only problem I have is that engine can run up to about 10,000 sustain, the generator, that is, motor, electric motor. It's got oil-like bearings in it, and what I really would like to do is replace it with a permanent magnet motor that runs on, that has ball bearings on it. This is a standard brushed 24-volt DC motor, the kind that are used in hair dryers, which end up on our dump fairly frequently because the elements burn out or they get clogged with air. So this is a standard cheap little motor, and it does the job quite nicely. And actually, you can buy them in a variety of different sites on eBay for $3 to $4 each. Shipping always costs more than the actual price, and it works pretty well. So I'm very pleased with it, and we can run it off of live steam, or we can run it off of compressed air. Okay. So let me just point out some of the features again of this little thing. And again, the actual turbine disc itself is made out of 6061 aluminum, cut with a CNC mill, and we're using a ball valve for a throttle, which isn't a great idea. It's not highly controllable. So what I'm going to do is put a needle valve in series with it, so I can get a quick shut off and shut on, and yet control the throttle very carefully. It's soft copper. The pipe is actually crimped at this end to form the nozzle. It can be pitched, changed pitch. The union here allows it to be removed and changed or modified in any way onto without upsetting the rest of the setup. And this is just a Lexan cover plate, PVC block to hold the turbine, and there's a double set of 2 ball bearings, high-speed ball bearings on the other side. They were cheap ones. I didn't invest in the really nice stainless steel ones, which you really should have on a turbine. And these are sealed ball bearings, and I have a feeling that the open stainless steel ones would work better with a very, very light machine oil on it. And the universal is working quite well, and as is the DC motor, 24-volt DC motor that's working as a generator. So all in all, I'm pretty pleased with it in this state of prototyping. Okay, we've done a little bit of a modification, and we've made the housing out of aluminum. And what we've done in the rear is we've attached this section here to it, which now contains the 2 high-speed ball bearings. The half shaft that comes from an RC dirt racing model car, and the same Johnson motor that I had before is there, and we've kept the flexibility of the being able to modify the input nozzle simply because I want to mess around with this a little bit more. But the housing is now made out of aluminum, and what we've done is put a standoff here out of Lexan, and of course the Lexan front cover. We now know that that's capable of withstanding steam, and so what we have is a sit-up that looks like this. And we'll be able to power it up. compression, the turbine noise.